Now, these examples show that the objects are acted upon by balanced forces. This first example is showing that the object is at rest. So, there are two forces acting on the object, the gravitational force and the normal force. Look at the length of the arrow. Look at the direction of the arrows. Okay? Observe the length of the arrows and the direction. So, the object is at rest. For this case, the object is moving because of the forward force. However, this forward force is counterparted by frictional force. For this particular example, the object is moving. Okay, the object is moving. However, the forces observe the length of the forces and the arrow's direction. Same as with this one and this one. Okay? So, this is an example of an object at rest. This is an example of an object in motion. What is similar with these examples? So, the two previous examples show balanced forces. What is meant by balanced forces? So the forces on the book are balanced. The table pushes upward on the book. Gravity pulls downward on the book. So if the forces on an object are equal in magnitude, meaning they have the same amount of force, and if you represent the forces in terms of force vector, the length of the arrow shows equal magnitude, and their directions are opposite. So, if the forces on an object are equal in magnitude, equal length, if you will represent it by arrows, and opposite in direction, they are said to be balanced, and the object experiences no change in motion. The object stays at rest. Now, what if the object is moving? Can we say that the forces are balanced? If the forces on an object are equal and opposite, so equal, the normal force is equal to the gravitational force, and they are opposite in direction. The frictional force is equal to the forward force, and they are opposite in direction. They are said to be balanced, and the object experiences no change in motion. The object stays in uniform motion, or what we call constant velocity. Okay? So there are two cases wherein an object will have balanced forces: when the object is at rest and when the object is in uniform motion. Here are some examples from real-life situation. So, again, the soccer ball experiences normal force and gravitational force. However, these two forces are equal in magnitude, and opposite in direction. So the object stays at rest. Okay? So it takes an unbalanced force or a kick to change its motion. Similar to these two teams playing tag of war, they are both exerting equal forces on the rope in opposite directions. So these balanced forces result in no change of motion. So for this particular game, there is no winner because they exerted equal and opposite forces. So the forces acting on the rope are balanced. One good example is little Nelly, who is hanging. Okay? So if you will observe, little Nelly experiences two forces, the tension force and the gravitational force. So the tension force should be equal in magnitude to the gravitational force. So if the gravitational force is 300 Newton, then the tension force is also 300 Newton. Now, if you will represent the tension force and the gravitational force in terms of force diagram, you will draw the tension force and the gravitational force from the same starting point and label it with the corresponding force, T and F sub G. So this is an example of a force diagram or a free body diagram. The forces are acting on one point. So we can say that they are concurrent forces. So force vectors are equal in magnitude and opposite in direction. So they are balanced. So if you will be representing 300 Newton in terms of an arrow, you can use a scale of 1 centimeter is to 100 Newton. So you will have a length of 3 centimeter to represent 300 Newton. So 3 centimeters for tension and 3 centimeters for gravitational force, so that you will represent the arrows in terms of force vector. So we can say that little Nelly Newton is at rest. So if the forces are equal in magnitude, opposite in direction, they are balanced, and they are concurrent forces, we can say that the object is in static equilibrium. So static equilibrium is a condition wherein concurrent forces acting on the object are equal in magnitude, opposite in direction, so they are balanced, and the object is at rest. Another example. So still, little Nelly Newton is hanging on the bar. So little Nelly Newton's weight is 300 Newton. And there are two tension forces acting on little Nelly Newton. So if it is 300 Newton, the weight is 300 Newton, what could be the value of the tension force between the two ropes? So these two ropes should equally distribute the weight of little Nelly Newton. So it will exert a tension force of 150 Newton. So 150 Newton for tension 1, for tension 2, and 150 Newton for tension 1. If you will observe, the length of the two arrows. Okay? So the two arrows have a shorter length. So, if you will represent these forces in terms of force vector, and with a scale of 1 centimeter is to 100 Newton, so you will represent this with 3 centimeter to represent 300 Newton. How about this one? So you will represent this with 1.5 centimeter, 1.5 centimeter. How are we going to prove that it is correct? So you draw your force diagram or your free body diagram. Okay, so tension 1, tension 2. So if you will combine them, T1 plus T2 will give you an equal length to FG. So if you will notice, the combination of the two tensions, okay, will be equal to the length of the gravitational force. So, since these two forces are acting on the center or one point on the object, we call them concurrent forces. So, again, force vectors that are equal in magnitude and opposite in direction are called balanced. Little Nelly Newton is still at rest. So, little Nelly Newton is in static equilibrium. Okay? So, what if the object is moving with uniform motion or constant velocity? We call it dynamic equilibrium. So, dynamic equilibrium is a condition wherein concurrent forces are balanced. So when we say concurrent forces are balanced, they are equal in magnitude, opposite in direction, and the object moves or the object stays in uniform motion or constant velocity.